Salutations, my mathematicians. My name is Professor Ramiro Santana, and today we will be doing a piecewise function problem that has two steps. The first is to find if the function is differentiable at x equals 1, and then, if it is differentiable at x equals 1, we must state what prime of f at x equals 1 equals. So first, we have our piecewise function, f of x equals 3x squared at the values x less than or equal to 1, and then 2x cubed plus 1 at the values x greater than 1. So in order to find if these two equations are differentiable, we must find their limit. So the limit of x to 1 through the left side must be equal to the limit of x to 1 through the right side. So let's find the limits individually and then find out if they're equal. Let's start out with finding the limit of x towards 1 through the left side. So the equation is 3x squared. We plug in the 1 and the value is 3. Now we find the second limit. X goes to 1 through the right side, and the equation is 2x cubed plus 1, and we plug in the 1, and so the result will also be 3. So with these results, we can conclude that both equations of the piecewise function are actually differentiable. So now we can head on to step number 2, where we find the prime of f using the limit process, and then find the value in that equation by plugging in 1. So as you can remember, the limit is as h heads to 0 of f of x plus h minus f of x over h. So we must apply this limit process to the both equations. So let's start with 3x squared, limit h to 0 of, and then we plug in the 3x squared into the equation, so we get 3x plus h squared minus 3x squared over h. And then as we continue, we get 3x squared plus 6x h plus 3h squared minus 3x squared over h. We get rid of the 3x squared. Then we continue. And so we have left 6xh plus 3h squared, all of that over h. So we can factor out the h value, so we can cancel that out. Plus 3h over h. So we cancel that and then continue. and we have left 6a plus 3h. Now we plug in the 0, and what we get is 6h. So the derivative of that equation is 6x. Now we must apply the limit process to the second equation, which is 2x cubed plus 1. So we do the limit process again. Cubed plus 1 minus 2 x cubed plus 1, all of that over h. And then we continue. Limit, so it's equal to 2x cubed plus 6x squared h plus 6h squared x plus 2x cubed plus 1 minus 2x cubed plus 1, all of that over h. We keep on. We cancel out the 2x cubed. We can also cancel out the 1s, and then on the next step we can also factor out the 2h. So in the numerator the factor can be 2h, and now we get 2h times 3x squared plus 3hx plus h squared, all that over h. We cancel out the h, and then our result will be 2 times 3x squared plus 3hx plus h squared. And then, so now we plug in the h0 into the equation, and so we plug in 0, x, plus 0 squared, and our final result will be 6x squared. The prime of f in the second equation is 6x squared. So now we must find what f prime 1 equals in these two equations. So our first prime, the first we calculated the derivative was 6x, and also the other one was 6x too. So we just like plug in the 1 into the x, and we get that 6 is the result. What f prime of 1 equals 6 on these two equations. So this concludes the process for the problem. I hope you understood everything, the process, and if there are any other questions you can contact me through the office hours. So that'll be the end of the lecture. Have a good day.